So now let us discuss how to score 30 marks in that 5 marks part in the second PU examination. Okay, so here I have mentioned very few questions in relations and functions. I already explained one or two problems. So before this, if you are not watched my first video, please watch that and subscribe to my YouTube channel. Okay, so 5 marks problem will be on finding the inverse by proving it as 1 1 and onto. So here I have one problem. This is also one of the important problems. I will only discuss 4 problems. In that 4 problems I already discussed one problem in my first class. So here we have, let f from n to r be a function defined as f of x is equals to 4x square plus 12x plus 15. F from n to s, where s is the range of f is invertible. First of all, we need to prove it as 1 1 and onto. We can do this problem by 2 different methods. I will show that 2 different methods. First of all, I will going for first method, that is proving it as 1 1 and onto. So to prove it as 1 1, we need to assume the given function as f of x1 is equals to f of x2. Okay, so now f of x is 4x square plus 12x square plus 15, means we can consider this one as 4x1 square plus 12x1 plus 15 is equals to 4x2 square plus 12x2 plus 15. So we can cancel 15 and 15 on both sides. Then we have 4x square plus 12x1. So for all these kinds of quadratic equation problems, we need to convert this one as a perfect square. Here we need 4x1 square. So what will be the root of, actually a plus b whole square? We know that a plus b whole square will be a square plus 2ab plus b square. Therefore in place of a square we have 4x1 square, means we can choose the first number as 2x1 plus, in place of 2ab already 2 is there and a I have chosen as 2x1, so it will be 4x1. So to get 12x1 we need to multiply it by 3. Therefore I will consider 2x1 plus 3 whole square. But what actually 2x1 plus 3 whole square is 4x1 square plus 12x1 plus 9. Therefore we need to consider minus 9 to that term to get 4x1 square plus 12x1. Similarly on the right hand side we can choose it as 2x2 plus 3 whole square minus 9, so that we can cancel 9 and 9 on both sides and squares on both sides. Then we get 2x1 plus 3 is equals to 2x2 plus 3. Again we can cancel 3 and 3 on both sides and 2 and 2. Then we have x1 is equals to x2. Therefore we need to conclude this result as f of x1 is equals to f of x2 implies x1 is equals to x2 for all x1 comma x2 belongs to, this function is defined from n to, means we need to write it as belongs to n. Then we need to prove this function as onto function. To prove it as an onto function, we need to take it as y is equals to f of x. Onto function, very easy method. Y is equals to f of x. Therefore y is equals to f of x is already mentioned as 4x square plus 12x plus 15. I have considered this 4x square plus 12x as 2x plus 3 whole square minus 9. So in place of this 4x square minus 12x, we can write it as 2x plus 3 whole square minus 9 plus 15 as it is. So now this is equals to 2x plus 3 whole square plus 6. This term will be plus 6. So that we can write y is equals to 2x plus 3 whole square plus 6. Therefore 2x plus 3 whole square is equals to y minus 6. Therefore 2x plus 3 will be square root of y minus 6, or 2x will be square root of y minus 6 minus 3. I will write the value for 2x. Then x will be equals to square root of y minus 6 minus 3. Should not consider square root for that minus 3 divided by 2. So here the function is from f from n to s, where s is already the range of f, means clearly you can say this function is a onto function. But we need x. That's why I've considered these steps. Therefore, x is nothing but f inverse of y. Therefore, f inverse, you need to write it as for all y belongs to prove it as onto, for all y belongs to this S, there exists x belongs to n such that y is equals to f of x, hence it is onto, hence it is bijective, hence it is invertible. Therefore, inverse of the function f inverse is from S to n. F inverse is from S to n given by f inverse of y. X is nothing but f inverse of y, which is equals to this particular step, square root of y minus 6 minus 3 divided by 2. Otherwise, you can write it as f inverse of x is equals to square root of x minus 6 minus 3 divided by 2. So this concludes this answer. So we need to prove it as 1 1 onto, then we need to consider inverse from S to n, and we need to write the inverse. This is first method. We have another method. So in that second method, we need to consider the value for x. Already we have considered x is equals to square root of y minus 6 minus 3, square root of y minus 6 minus 3 divided by 2. We need to find the value of x. Then we need to consider FOG and GOF. Already this is f inverse or g, f inverse or g. The given function f is f of x is equals to the given function is 4x square plus 12x plus 15. 4x square plus 12x, 4x square plus 12x plus 15. Therefore, we need to choose FOG and GOF. FOG of x is equals to FOG of x means it will be f of g of x or g of y. You can consider g of y also. G of x means you need to replace this y by x. I will consider this one as FOG of x itself. Then it is f of, so this is g of y. Otherwise you can choose y itself. So if you have chosen y, this is also is equals to y. F of square root of y minus 6 minus 3 divided by 2. Now f is a function such that which converts 4 into element square plus 12 into element plus 15. Therefore it will be 4 into, so what will be the square of this? Square root of y minus 6 minus 3 divided by 2 the whole square plus 12 into element. Element will be square root of y minus 6 minus 3 divided by 2 plus 15. So here 2 and this means it will be 6 here. So this is equals to, here this is 2 square. 2 square and 4 get cancels. We have square root of y minus 6 minus 3 the whole square. It will be y minus 6 plus 9 minus 6 times square root of y minus 6 plus, if you multiply this one, then again you will get 6 into square root of y minus 6 minus of 18 plus 15. Therefore this y minus 6 and this y minus 6 get cancels. This 6 is equals to, now this is 15 minus 3. So 15 minus 18 will be minus 3. This is 9 minus 6. It will be again plus 3, that get cancelled. So is equals to y, we get FOG of y is equals to y, means it's an identity function. Therefore FOG is equals to, we can write I s, because g is a function starts from s. Similarly we can consider GOF of x is equals to g of f of x. F of x will be here. So f of x is given function g of f of x is 4x square plus 12x plus 15. Already we have considered this one as g of 2x plus 3 whole square minus of 2x plus 3 whole square plus 6. We have considered this one as plus 6. Therefore, this is equals to g is a function which converts the square root of element minus 6 minus 3 divided by 2. So, it will be square root of element is 2x plus 3 whole square plus 6 minus 6 minus 3 divided by 2 is equals to 6 get cancels and also square root and square get cancels. 2x plus 3 minus 3. We have only 2x divided by 2 is equals to x. Therefore, GOF of x is again identity function. Therefore, GOF is equals to IN. This is also we need to write because it's a function starts from f means f starts from n. Therefore, f inverse is given by f inverse of y is given by this particular function. So, we shall consider a few more problems. So, here we may have the problems like 4x plus 3. So, that 4x plus 3 I have already solved, and x square plus 4. So, here also we can prove it as 1 1 and on 2 just by x1 square x1 square plus 4 is equals to x2 square plus 4, then cancelling 4 and x1 is equals to x2. We can prove this, and also we can prove this function as a onto function. Then we have 9x square plus 6x minus 5. So again the same procedure I have explained for quadratic equation, but I will consider this particular problem of x divided by x plus 2. So briefly I will explain that x divided by x plus 2 problem. To prove it as 1 1 function, we need to assume f of x1 is equals to f of x2. Then it will be x1 divided by x1 plus 2 is equals to x2 divided by x2 plus 2. So whenever you have denominator terms, then to prove it as either 1 1 or on 2, you need to consider the cross multiplication. So here if you consider cross multiplication, then it will be x1 x2 plus 2x1 is equals to x1 x2 plus 2x2. You can cancel x1 x2 on both sides and 2 and 2 on both sides. X1 is equals to x2. So you need to write it as for all x1 comma x2 belongs to domain of the given function, f of x1 is equals to f of x2 implies x1 is equals to x2. Then y is equals to f of x to prove it as onto. Then f of x is equals to x divided by x plus 2. To prove it as onto, our intention is to find the value for x. Therefore, again by cross multiplication xy, this cross multiplication it is xy plus 2y is equals to x. Then taking the terms containing x onto one side, it will be xy minus x is equals to minus 2y, and if you take x outside, then it will be x is equals to, I will skip one step to write it as minus 2y divided by y minus 1, or it will be 2y divided by 1 minus y. Here also you need to mention for all y belongs to range of the given function, there exists a x belongs to domain of the given function such that y is equals to f of x. If you study these 5 problems, definitely you will get 5 marks from relations and functions. So I will explain how to choose that 5 problems. So out of that 10 questions, you need to choose one question from relations and functions, and also you can do it matrices and determinants. So 3 questions. Then fourth one will be second order derivative, and fifth one must be application of derivative, and sixth one must be integrations derivation. So I'll give you few more options here. So matrix problem, sometimes matrix problem is very lengthy. Even though it's a very easy problem, it consumes a lot of time. Therefore you need to avoid that matrix problem, and immediately you should go for 3D derivation. 3D derivation is fixed. So problems takes times because you need to think about it, but derivations are exactly as like the given things. Therefore you need to go for derivations. So if you don't know 3D derivation, then you need to go for this matrices only. And again I will give you one more option. If determinant also a bit lengthy, then you need to go for the probability problem. So that probability problem also very easy. Then you can have one option of taking a problem on differential equation, because differential equation problem is very easy. Application of integration problems are a bit lengthy. Therefore better you take that kind of problems in the second level, because it's time consuming. So first you do all these problems, then if you have time, then go for that. So now I will explain few matrix multiplication problems. So here I have one problem that A, B, C is given. A, C, B, C, find A plus B into C. Also verify that A plus B into C, AC plus BC. Matrix multiplication is very easy. So here you can find A plus B easily. A plus B into C. To find A plus B into C, you need to write the orders here. What is the order of A plus B? Order of A plus B is 3 cross 3. What is the order of C? Order of C is 3 cross 1. So you need to take these two common, otherwise matrix multiplication is not possible. Then the resultant matrix will be of this particular order, this first number and this last number. Therefore, in the required matrix, you need 3 rows and 1 column. So you need 3 rows and 1 column. Okay. So first row, second row, third row it is. Now, which position it is? First row, first column. You need to choose first row from A plus B and first column. So in fact in that C you have only one column, no problem. You need to choose this first row and first column. Then you need to multiply 0 to 2, 7 to minus 2, then it will be minus 14, 8 to 3. So it will be 24. Therefore 24 minus 14 will be 10. Here you will get 10. Next, which position it is? It is second row, first column. Therefore second row means you need to choose second row from first matrix. First column means here you have only 1. Therefore it will be minus 5 into 2, 0 into minus 2 plus 10 into 3. Therefore here you will get the value as 20. So after this, which position it is? This is third row, first column. You need to choose third row from first matrix and first column from second matrix. Again it will be 8 into 2 minus 6 into minus 2 plus 0 into 3. Therefore it is 16 plus 12 is equals to 28. So in a simple manner you can find this A plus B into C. Again in the same manner you can find AC. Again here you have 3 cross 3, here you have 3 cross 1. The resultant will be of the order 3 cross 1. You need to multiply this row by this column, again this row by this column, again this row by this column, and you need to add that, sorry, one second, A plus B into C is already known. This is equation 1. Then you need to find BC in the same manner. This is 3 cross 3, 3 cross 1. The resultant will be 3 cross 1. So this is first row, first column. This is product of first row, second row, first column. This is product of third row, first column. Now you have all these values. If you add 2 and 3, then you will get equation 1. So this is how we can easily perform matrix multiplication. So I will give few more examples. So this is one of the better examples. So this question is asked, I think, in the 2016 examination. So here A is equals to B is equals to given. Verify that A into B whole transpose is equals to B transpose into A transpose. This is a simple problem. So calculation is very lengthy. If these kinds of problems are asked in the examination, you need to attend these problems on matrices. But you should careful to find this AB, because many students will be in the confusion that whether which order to be considered. So again the same concept. A is of order 3 cross 1 because you have 3 rows and 1 column. B is of order 1 row and 3 column. So 1 and 1 is common, therefore resultant will be of the order 3 cross 3. Therefore we shall consider AB, A into B is equals to, so here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Again which position it is? First row, first column. Multiply first row by first column, then it will be minus 2. Then second row, first column, then it will be 4 because in second row you have 4. First column 1. Then first row, one second, so this is first row, second column, then it will be minus 2 into 3. First row, second column, minus 2 into 3 will be minus 6 here. Then this is again first row, third column. Therefore first row should be multiplied by third column, minus 2 into minus 6 plus 12. Similarly this is second row position. Second row means here we will get 4, 4 3s are 12, 4 into minus 6 will be minus 24. Similarly you can find this is third row, first column. Third row should be multiplied by first, second, third column. So then it will be 5, 15 minus 30. Okay, so this is AB, but you need to find AB the transpose. Transpose can be easily find out by interchanging rows and columns. So here we consider minus 2, 4, 5, minus 6, 12, 15, 12, minus 24, minus 30. So we can easily find like this. Then we need to prove it as B transpose into A transpose. So B transpose will be 1, 3, minus 6 into A transpose will be minus 2, 4, 5. Therefore again this is of order 3 cross 1. This is of order 1 cross 3. The resultant will be of the order 3 cross 3. You can use the same concept to find this particular value. Okay. Then so here again, so here we need to find A into B. So whether A into B is defined or not, this is of order 2 cross 2, and this is of order, here we have 2 rows and 3 columns. Therefore we can find A into B. Resultant will be of the order 2 cross 3. 2 cross 3 means we have 2 rows and 3 columns. 2 rows, 3 columns. This is first row, first column. So first row 6, here you need to choose first row from first matrix, first column from second matrix. 6 into 2 is 12, 12 plus 9 sevens are 63. Next similarly, this is first row, second column, then it will be 6 into 6 is 36 plus 9 into 9 will be 81. Then first row, third column, 6 into 0 is 0, 9 into 8 will be 72. Similarly, you can find second row, first column. 2 into 2 is 4. Second row, first column. 2 into 2 is 4. 7 into 3 is 21. So 4 plus 21. This is second row, second column. 2 into 6 is 12 plus 9 into 3 is 27. Then second row, third column. 0 plus 24. If you add all these two, then 75 plus 80 plus 30 will be 110, plus 6 will be 117. Sorry, 117. This element is already 72. This is 25. This is 27 plus 12 is 39. This is 24. You can easily find A into B. So one more problem. You may ask like the problems like A is given A cube minus 23A minus 40I is equals to 0. So to find A cube, first of all you need to find A square. So A square means again you need to write A into A. This is first row, first column. Therefore first row should be multiplied by first column. This is first row, second column. First row should be multiplied by this second column. So I will write as 1, and this arrow is 2, this arrow is 3, this arrow is 1, this arrow is 2, this arrow is 3. So you can easily find A square. So after finding A square, A cube will be A into A square. Again first row should be multiplied by first column. You should look at which position you are. So this is first row, first column. So if you want to find this value, third row, second column, you need to multiply third row by second column, and you need to add all such elements. So you can find this. So already I have done this particular problem also. So next important question will be solving the system of equations by matrix method. This is also one of the definite question. So this is a very easy problem. I will explain how to solve this particular problem. Here you need to consider the determinant solution of this by matrix method. So A is equals to, carefully observe this, A is a matrix of coefficients, that is 3, minus 2, 3, 2, 1, minus 1, 4, minus 3, 2. And you need to take matrix X as unknown values. Here X, Y, Z are unknown. Suppose in sometimes they may give like 2 by X plus 3 by Y plus 4 by Z problem. Then you need to consider 1 by X, 1 by Y, 1 by Z. Here you need to consider X, Y, Z as the unknown values. Then B is a matrix of constants. Here 8, 1, 4 will be the constants. So immediately after this you need to write A into X is equals to B, or X is equals to A inverse into B. This is equals to A inverse is adjoint of A divided by determinant of A. Then how to find adjoint of that matrix? Adjoint of the given matrix is given by adjoint of A is equals to A11. You need to write A12 in this position. This is very important. A13, A21, A22, A23, A31, A32, A33. Then, so what will be A11 like this? First of all, you need to write A11, A12, A13, A21, A22, A23, A31, A32, A33 is equals to. So now you need to start with plus. So this value will be plus, this will be minus, plus. Whenever you have plus, I don't write that plus. So after this plus you have minus here. Plus, minus, plus, minus, plus. Okay, this is first row, first column. First row, first column means you need to leave first row and first column. Then you have these particular elements. So you need to leave this. In the examination also, if you are not perfect with this, just mark like this in the pencil. Then you have this 1 into 2 minus 3 into minus 1. So 2 minus 3 will be minus 1. This value will be minus 1. So after getting this value as minus 1, you need to leave first row. You need to leave this first row and second column. If you leave first row and second column, you are remain with 2 minus 1, 4, 2. Therefore, 2 into 2 will be 4. Here, minus 4 into minus 1 will be plus 4. 4 plus 4 will be 8. But here you have minus sign outside of that. Therefore, that element will be minus 8. Next, first row. You need to leave first row, third column. So you just leave this first row and third column. Then it is 2 into minus 3, which is minus 6, minus 4. Minus 6 minus 4 is minus 10. Then here you have second row. Now you need to leave second row. So what you do is, first of all, erase that second row. Then erase one by one. If you are not perfect, then only. So if you are perfect, then you can do the calculation directly. Second row, first column. Then it will be minus 2 into 2, minus 4. If you leave second row, first column, then second row. Just mark here. This is second row. Then first column. First column. If you leave this first column, then you have minus 2 into 2, 3 into 3. Okay. So minus 2 into 2 is minus 4. Minus 3 into means it will be plus. Minus of minus plus. So 9 minus 4 will be 5. Here you will get 5. But you have minus sign outside of that. So it will be minus 5. A22. Leave second row, second column. Then it is 3 into 2, 6. 6 minus 12, minus 6. Here you will get minus 6. A23. Second row, third column. If you leave second row and third column, 3 into 3 is minus 9. So sorry, 3 into minus 3 it is. Then you have 4 into minus 2. So then it will be minus 9 plus 8. Then it will be minus 1. But you have minus outside of that. Therefore it will be plus 1. So then you have 3, 1. A31. Third row, first column. Then it is minus 2 into minus 1 is plus 2. Plus 2 minus 3. Plus 2 minus 3 will be minus 1. Then third row, second column. If you leave third row and second column, 3 into minus 1 is minus 3, minus 6, minus 9 it is. So here you have minus of minus plus 9. This element will be plus 9. Because here minus plus minus plus minus plus minus plus minus plus minus plus. So then third row, third column, third row, third column. Then it will be 3 plus 4. 3 plus 4 is 7. So you need to write all these values. Now in place of adjoint of A, we shall substitute this. So again I will explain one hint. Determinant of A can be easily find out using multiplying these all by first row, that is 3 into minus 1. This 3, A11, that is actually A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13. If you add all these, then it will be 3 into minus 1 minus 3 plus you will get second element will be minus 2 into minus 8 plus 16 plus 3 into minus 10 will be minus 30. So minus 3 plus 16 minus 30 means you will get minus of 17. So now multiply this A11, substitute the values here, then it will be 1 by A. Actually x is equals to A inverse into B. Already A inverse is adjoint of A divided by determinant of A into B also we have. Therefore I will substitute minus 1 by 17 into minus 1 minus 8 minus 10 minus 5 minus 6 plus 1 minus 1 9 7 into 8 1 4. So if you multiply this, then you will get minus 1 by 17 is equals to, so again you will have 3 rows and 1 columns, 8 into 1 it will be, then 1 into minus 5, 4 into minus 1. So minus 8 minus 5 will be minus 13, minus 4 will be minus 17. This value will be minus 17. Then here you have, I think minus 8, this value is minus 8. Therefore minus 64 minus 6 minus 70 plus 36. Therefore it will be minus of 34. This value will be minus 34. Similarly, if you find this value minus 80 plus 1 plus 28, therefore which is equals to minus 51. If you divide it by minus 1 by 17, then you will have 1 2 3. Therefore you can write x is equals to 1, y is equals to 2, z is equals to 3. This will be the solution. You can verify your answer by substituting all these values here. So if you substitute x is equals to 1, y is equals to 2, z is equals to 3, what happens? So 3 into 1 is 3, minus 4 plus 9. So 3 plus 9 is 12, 12 minus 4 is 8. Similarly you can substitute here and here also. Therefore you will get the required answer here.